When you ask a standard AI to build a web page from a screenshot, the result is usually static. The model can describe the pixels, but it cannot comprehend how the elements actually function. We now have AI models that bypass this limitation entirely. They actively navigate, click, and read the document object model of live websites, specifically Z.ai's GLM-5V Turbo. This model can autonomously explore a target website, map the internal page transitions, and generate a fully functional clone directly on your local machine. To set this up, you need three components: your Z.ai API key, a Node.js environment, and a local agent gateway like OpenClaw installed on your system. A model that tests its own code against a live environment builds working software. A model guessing from a single image only builds mockups. Open your terminal. First, export your API key as an environment variable. Then, configure your OpenClaw settings to route tasks to the GLM-5V Turbo model. Notice how visual data and textual instructions flow simultaneously into a single encoder called CogViT. Older systems align vision and language using separate plugins. Those bolted-on modules break away here, removing the latency between what the agent sees and types. Z.ai trained this model using joint reinforcement learning across more than 30 different domains. It maintains strict programming logic while accurately locating buttons and menus on a screen. Because of this native training, the agent perceives a graphical user interface exactly as you do, as a fluid, interactive environment to be navigated. Back in the terminal, initiate the agent. Write a command instructing OpenClaw to launch a browser session and navigate to your target URL. You must be explicit in your instructions. Tell the agent to map transitions, collect all visual assets, reconstruct the user interface using React and Tailwind CSS. Do not let the agent run without boundaries. The most common point of failure for autonomous browsers is getting trapped in an infinite scroll loop on dynamic pages. You prevent this by adding strict parameters to your prompt. Tell the model to limit its exploration to a depth of 3 clicks, or cap the total number of pages it visits at 5. Giving an agent the ability to click anything requires telling it exactly when to stop. Proper constraints keep the model focused on building your project instead of endlessly cataloging data. Hit Enter. You'll see a split-screen workspace. The terminal logs decisions on the left, and an automated Chrome window renders the site on the right. Watch the browser window. The agent applies bounding boxes around individual elements, matching the visual layout to the document object model to extract the site's structural hierarchy. Keep your mouse away from the browser window. Any manual clicks will disrupt the agent's spatial granulometers and corrupt the code generation. While it runs, monitor the terminal logs for your API usage. GLM-5V Turbo has a massive 200,000 token context window and charges $4 per million output tokens, so keep an eye on your consumption. Seeing the agent evaluate the page, plan a click, and execute it in real time proves this system is operating as an active digital worker rather than a simple text predictor. Once the exploration hits your depth limit, the agent writes the complete set of React components and Tailwind files directly into your local system directory. Type CD followed by your new project directory name to navigate into the folder. Then run npm run dev to initialize your local development server. The Node.js environment will process the agent's code. You should see a success message indicating the project has compiled, followed by a local host URL. Click that local host link. A new browser tab will open, displaying the standalone, functional clone of your target website running entirely from your local machine. The process of moving from a target URL to a fully hosted local environment demonstrates how visual exploration directly translates into executable software architecture. Open the original website and your new local host clone side by side. Compare the visual fidelity of the layout, checking for pixel-level accuracy in the component spacing and color palettes. Next, click through the navigation menus and buttons. Ensure the agent correctly mapped and implemented the internal page transitions and underlying component logic. If a button is misaligned or a color is off, use the model's native code debugging skill. Take a screenshot of the specific error, feed it back into OpenClaw, and the agent will automatically locate and patch the front-end code.
By replacing manual syntax entry with autonomous GUI exploration, developers spend less time typing boilerplate, acting instead as orchestrators of an environment-aware digital workforce.